Okay, so think about any modern application. You've got dozens, maybe even hundreds of different software components that all need to talk to each other. How in the world do they do that without creating this tangled, chaotic mess? Well, that's where Amazon EventBridge comes in. It's all about bringing order and clarity to that chaos. So let's dive in and see how it really works. Here's the game plan. We're going to start with the core problem, how apps talk to each other. Then we'll see how EventBridge acts as a central router, how it handles those simple one-to-one connections, and even how it puts tasks on a schedule. We'll also get into the super important topic of reliability, what happens when things go wrong, and we'll wrap it all up with a look at your complete event-driven toolkit. All right, let's set the stage. In today's world of microservices, getting all the little pieces of an application to work together smoothly, well, that's one of the biggest challenges for developers, for sure. And that really brings us to this central question we're tackling here. How do modern apps talk to each other effectively? Turns out there are two pretty different approaches. So on the left, you've got the old way. Think of it like a chain of people holding hands. One person has to tap the next on the shoulder, who then taps the next. It's direct, sure, but if one person trips, the whole chain can come crashing down. Now on the right, that's the event-driven way, and it's what EventBridge is all about. Here, components don't talk directly. Instead, one part of the system just shouts out, "Hey, I just did something." That's an event. Any other part of the system that cares can listen for it and react. The original component? It has no idea who's listening, and it doesn't have to care. This idea of being loosely coupled is what makes these systems so powerful and resilient. So how do you manage all these events flying around everywhere? You need a smart traffic cop, right? Something to solve that many-to-many routing problem. And this is where the event bus comes into play. An event bus is basically a central hub that all your events pass through. The best way to think of it is like a central post office for your application's data. A service drops off a letter, that's the event, and the event bus looks at the address, checks its rulebook, and figures out exactly who needs a copy. It might deliver it to one target, or 5, or maybe even none at all. The sender never has to know who the final recipient is. Now, one of the really powerful things EventBridge can do is route events between different AWS accounts. But it wasn't always this easy. In the past, it was this clunky, multi-step process. An event would leave account A, get forwarded to this special bridging bus in account B before it could finally get to its destination. And that extra hop, it wasn't just messy, it added delays and created a major headache when it came to security. Every single connection meant setting up these complex permissions between accounts, which really slowed down development. But now, just look at how clean this is. An event leaves account A and gets delivered directly to the target in account B. No bridge, no extra hops, no complicated permissions. This is a perfect example of how EventBridge just cuts through the complexity, making your whole system faster, more secure, and way easier to manage. Okay, so event buses are fantastic for that big, complex, many-to-many routing. But what if you have a much simpler job? What if you just need a reliable way to connect one single thing to one other single thing? For that specific job, you use an EventBridge pipe. It's designed just for these simple point-to-point integrations. So if the event bus is the post office for the whole city, a pipe is like a dedicated pneumatic tube that shoots a message from your desk directly to one colleague's desk, and that's it. And here's where pipes get really cool. Let's walk through this. Let's say your source is a Kafka stream, and it's sending events in a format called Avro. The problem is your target service only understands JSON. Well, the pipe has this built-in enrichment step that can run a little bit of code on the fly to translate that event from Avro to JSON, delivering it perfectly formatted every single time. And this is a real game changer. As the AWS team says, pipes reduce the amount of integration code you have to write and maintain. The bottom line is, you don't have to build and manage all that custom glue code yourself anymore. The pipe handles the plumbing, and that means less work and fewer bugs for your team. So far, we've been talking about an event from one service kicking off an action in another, but what if you need something to happen based on the clock? Like, say, running a report every single night at midnight. Well, that's a job for the EventBridge scheduler, and the scale here is just massive. It's a fully managed service that lets you create and manage literally millions of scheduled tasks, which can then trigger just about any action across more than 270 different AWS services. It's incredibly powerful. You've basically got 3 ways to schedule things. Rate-based is the simplest. Just run a job every 15 minutes. Cron-based gives you super fine-grained control for more complex schedules, like at 10:15 on the last Friday of every month. And don't worry if that syntax looks a little intimidating, there are plenty of tools to help you build those expressions. And finally, you have one-time schedules, which do exactly what they sound like. Run a task just once at a specific time in the future. Okay, so we've designed this beautiful, fast, scalable, event-driven system. But what happens when things go wrong? What if one of your target services gets overwhelmed and just starts failing? We absolutely have to talk about reliability. This chart tells the whole story. In this situation, we successfully delivered 500 events. That's the bar on the right. But because the target was overloaded, EventBridge automatically retried the failed ones, which added another 700 retry attempts. So our system had to handle 1,200 total attempts, more than double the traffic, just to get those 500 events through. This is exactly why you have to monitor for retries. And here's the real-world cost of those failures. Look at this number, 597,621 milliseconds. That is nearly 10 minutes for an event to finally get delivered. For any app that needs to be responsive, a 10-minute delay is an absolute eternity. So what happens if an event still can't be delivered, even after all those retries? Does it just get lost forever? Nope, absolutely not. That's what a dead letter queue, or DLQ, is for. It is your ultimate safety net. If EventBridge finally gives up, it sends the failed event to this special queue so you can analyze it later and make sure that no data is ever lost. All right, let's bring it all together. The best way to think about EventBridge isn't as one single product, but as a powerful toolkit with a specific, specialized tool for every single job. And here it is, your toolkit. For that complex many-to-many routing, you use an event bus. That's your central post office. For simple, direct A to B integrations that need a little data transformation, you grab a pipe, your dedicated pneumatic tube. And for anything that needs to happen based on the clock, you use the scheduler, your highly reliable alarm clock. By choosing the right tool for the job, you can build these incredibly resilient, scalable applications that really do move from chaos to clarity. So the only question left is, with this toolkit in your hand, what problem are you going to solve next?